Emergency warning is in place in Sydney's southern suburbs tonight after a fierce wind change saw homes come under ember attack from a fast-moving bushfire.
Ember showers, ember rainstorms effectively showering down on firefighters, showering down on communities.
The blaze started near Kashula train station yesterday afternoon. It's now a crime scene. Investigators suspect it may have been deliberately lit.
Here we have the internal components of the FireSense unit. First we have the Arduino Uno microcontroller. Next we have an ionization smoke alarm. Next we have a configurable threshold thermostat. And finally we have a Bluetooth communication module. Here we have the internal FireSense unit components. We have the Arduino Uno backbone, the ionization smoke alarm, the threshold thermostat, and finally the Bluetooth module. The Arduino Uno forms the backbone of our FireSense unit, controlling and integrating every module of our product. And here we have the ionization smoke alarm. This component forms the namesake of our device, FireSense. When this detector detects smoke, it will trigger the board alarm and also send a signal to the Arduino Uno base. And here we have the threshold thermostat, which contains a configurable trim pot, which will be preset to a certain threshold temperature, which will be activated when the Arduino Uno queries this component. This unit will only be used if a positive smoke detection is detected by the smoke alarm. And finally, we have the Bluetooth module, which forms arguably the most important component of our device. This unit utilizes the Bluetooth protocol, which communicates between the user interface on the user device and our FireSense units. This module will always be running, searching for a pairing with a user device.
We decided to make our system self-sustainable and self-sufficient by using renewable energies as a power source. With the use of the DC-DC buck converter, we were able to step down the voltage from the 15 volts collected from the solar panel down to the 5 volts. NIMH battery was used as a rechargeable battery source to power our FireSense system.
So in order to make our product FireSense working in an outdoor area with self-sustainability and self-efficiency, we decided to use a solar panel to power up our system. This is a 10-watt solar panel to charge our rechargeable battery, and the material of this is single crystal. Comparing with two other materials in the market, which is polycrystal and amorphous silicon, this one gets the most transfer efficiency and longest operating life and great stability, but the average price is 4 to 6 per watt, which is the highest.
For our FireSense product, we've created an app to receive a notification when a fire has been detected. This is the initial page, preventing the outspread of fires one notification at a time. We could see that it is now scanning for the sensors. and it has been connected to the kitchen sensor. You can go to manual mode and select a Bluetooth device.
This is the first prototype we designed and built. I did the 3D rendering using the Tinkercad software. It has a diameter of 85 millimeters and a height of 60 millimeters. As you can see, it has a dome top, which I thought looks really nice. And it has the lettering in front of a FireSense product. And if you look at the back, you can see the vents where the smoke can go in and trigger the alarm. It's made out of ABS plastic, and I was able to send this design to David Latter at RMIT Building 10 Level 9. And as you can see, it's a cylindrical design, so that air can pass around it and go inside the vents better and trigger the alarm more efficiently.
So here we have the second iteration of the FireSense unit. We decided to go with a much more smaller design to make sure it's much more efficient and compact. To be included in the final design of the FireSense unit, we have the smoke sensor with the ionization chamber, the MPPT tracker for the solar panel, the thermistor to detect levels of temperature intensity, finally communicated by the HC05 Bluetooth sensor. All these components will finally then be soldered on to the soldering board to ensure all components are tracked with each other. The solar panel will then be connected by the rechargeable battery to power on the entire system. Here we have a bit of history, the initial FireSense design, and finally, the second iteration of FireSense.